my name is Pierce, and with me are my team members Raghav, Melissa, Jack, Arun, and Jacob. And for our 460J final project, we explored fine-tuning / transfer learning applications of generative adversarial networks and clip models to create NFT or non-fungible token artwork. For the uninformed, NFTs have become the new hot topic in the cryptocurrency space. It is a piece of data on the blockchain ledger that is unique, and they are typically associated with a piece of digital art such as a photo, drawing, or video. In our project, we aim to generate art in the style of current popular NFT collections based on text prompts automatically. This acts as a platform for a learning experience in generative adversarial networks and natural language processing. Also, the generated images could potentially be registered as actual NFTs that people can buy and trade, which would have a novel or unique context compared to human-drawn NFTs. As an example of our architecture, the user will provide an input in the form of a prompt. For example, in this slide, we have an NFT of a green monkey with glasses and an orange hat being the requested image. And then our model will subsequently produce such an image with all of the features matching the description.
The first challenge for the team was how to best scrape, collect, clean, and combine a diverse but plentiful set of NFTs in the art category. Thankfully, compared to other possible topics, the NFT space is well documented and available online for us to explore. We found a robust API to collect images and metadata on OpenSea.io. The API allows us to scrape from thousands of NFT art collections that each contains thousands of individual NFT art pieces. We generated an API key to use for OpenSea and wrote a script to download NFT images and metadata based on an input YAML file. This is an example input YAML file for the scraping script. Essentially, we just needed to document which collections we wanted to scrape and the number of pieces per collection. Then the script automatically collected the art pieces and its metadata for us. OpenSea had an index of collections which could be sorted by recent activity, which is what we used to determine which collections to scrape from, as we wanted our dataset to be representative of current trends. An issue the team experienced with our script to scrape images was that the OpenSea API had rate limiting. In order to collect a dataset with enough diversity and volume, the team had to run the web scraper across multiple days, machines, and keys. On the right, we can see the 18 collections that we scraped from OpenSea.io for a total of just less than 80,000 images. For ease of use, we additionally reformatted the metadata into a cleaner YAML file that only contained the useful data needed to generate labels for our scraped images. Here on the right, we can see the 18 collections that we scraped from OpenSea.io for a total of just less than 80,000 images. For ease of use, we additionally reformatted the metadata into a cleaner YAML file that only contained the useful data needed to generate labels for our scraped images.
After doing some research, we found that the StyleGAN model met all of our requirements for generating high-resolution images with a specific style that we could create using transfer learning and our dataset. StyleGAN is a generative adversarial network. Shown is the model architecture. A high-resolution image is generated using the latent code shown on the leftmost side. After some more research, we also found the clip model. While clip has many advantages and potential applications, the main benefit for our purposes is its ability to generate a likeness score between an image and a text prompt. What this allows us to do is create a dual model architecture to generate images based on a prompt. Shown here is our final architecture. Essentially, we start with the random latent code and our user's given text prompt. The GAN will generate a random image from the latent code, which we will then give as an input to clip, which will generate a likeness score between the user's prompt and the image. Using that score, we will apply gradient ascent to move in the direction of an increasing likeness score by updating the latent code. We will do this over many iterations until the latent code stops changing or the user finds the image to be sufficient.
Now we will be going over the results of our project. At first, we trained a single StyleGAN v2 on all NFTs that we scraped from OpenSea API. The StyleGAN was able to create realistic NFT style art in many cases, but a large portion of the image contained strange aberrations. We decided that a few of the collections that we scraped did not match the stereotypical style of NFT art, and this was resulting in poor quality images.
So to iterate on our first StyleGAN v2, we decided to restrict our dataset to only about 9,000 images from collections that contain cartoonish faces or animals. And so by doing this, we are able to achieve a lot better results on our image generations, and StyleGAN v2 is able to not only make realistic looking NFTs, but also effectively mix the different styles of NFTs as well. So building on our results from StyleGAN, we decided to further restrict our dataset to only NFT collections that contain apes. So apes are a very common style of NFT art. And you can see here we use lightweight GAN, which is a smaller GAN architecture than StyleGAN, but it's still able to capture the distribution of the data in only 12 hours of training on a single GPU. This GAN even learned to create the fast food logos on the hats for one of the NFT collections. To further build on our results from the lightweight GAN, we trained Clip, which is a image and language model that associates different captions with actual images. So here we generate images using a random latent vector for the lightweight GAN, and then we score the output image based on a caption using Clip, and then we backpropagate through the network to the latent vector to search over the latent space of the GAN to get an image based on a caption. So here you can see a few different examples of the actual training process at each iteration for this image generation. And so we're actually able to create NFTs from captions that are somewhat accurate. So there's a lot of applications for this, and also it's just pretty cool that you can create NFTs from just a caption and a sequence of words.
In our attempts to integrate our GAN models with Clip, we realized that there were issues with our original design, most notably Clip being trained on ImageNet, which contains photorealistic images of various objects. This does not translate well for our purposes, since, for example, Clip's notion of various features would vary drastically from the cartoonish or non-photorealistic features of the NFTs. To address this, we performed fine-tuning on Clip using our NFT dataset, creating prompts from the scraped attributes of each NFT. There were also drastic artistic differences between collections and consequently different representations of the same features, mix of attributes, etc. across collections, and this would effectively have the model learn these collections and their attributes independently. Instead, we opted for a modified pipeline that would generate images from one collection instead of trying to generalize to all NFT art, as we found this to be too vague in this application. We fine-tuned our GAN and Clip on a single sufficiently large dataset, in this case the Bored Apes Yacht Club collection, and as a result features were more uniform since there was no clashing between drastically different art styles, and the prompts made much more sense since in this context you would be describing an ape with certain attributes rather than a poorly defined generic NFT with various attributes.
Now, one possible unique application in this space of NFTs would be the customization of personalized NFTs via a prompt. You may generate novel artwork fitting the description for eventual minting on the blockchain. And with this sort of system, the buyer may potentially describe the NFT that they want and then purchase it. Now, ideally, you would have a large supporting data set underlying this system so that you get better training and then ultimately better results.